this because, all right, great. So any questions so far? Right now, we got nothing. All right. So the plan I have right now is not much of a plan at all. The plan I have right now is hopefully people ask questions as I go along because I tend to ramble. We're going to look quickly at what the heck this hash table sample code does. The sample code, great question. So the question is, in case my chat's not showing up here, is the provided code exactly going to be on the exam? The provided code is exactly going to be used on the exam. As in, I might say, use this hash table, or make a class that has a hash table, or I'm going to extend this hash table, or extend this hash table, or let me think of a good example. What would happen if I added these items into this hash table? Right? It's the idea that you would have to understand some code, which is stuff that all came from the lectures. It's not something new that I came up with. Also done in the assignments. You have to understand how those particular things work. You would need to be able to extend classes, for example, be able to use different classes, use standard libraries potentially. I wouldn't be saying, hey, call quicksort, because that's one of those, did you memorize this? And you can always look it up online anyways. But things like you're using a linked list and okay, yeah. So I did one exam question was, which is not going to be on it because I think I gave it as an example, make a queue using a linked list. So I gave the linked list code. You can make a queue with a linked list by just making essentially a queue data structure, but inside the queue, there is a linked list. Used add to the front, and it's a queue, right? So it's add to the front, root for the back, or whatever the case is, or the other way around. No, linked list that showed up in assignment 3 as well. Redoing assignments is useless. You're wasting your time. A whole bunch of computer science professors and I were talking at a community of practice thing, and we got the tree nodes does not use a linked list at all. It would be good for figuring out what a tree is, but we also did a tree with structure with objects. But the reason a lot of students always want to redo an assignment. You're like, why? Why would you redo an assignment? I am telling you, a hash table is on the assignment. This hash table. I'm not going to ask you to reproduce that hash table. I'm not going to say, hey, what line was wrong? But to understand that hash table, if you're going to use the hash table, so what I was going to look at is, let's make a student register. So student registration, it's going to take a whole bunch of student objects, throw them in the hash table, pull out an individual student from the hash table. That is me using a hash table to solve a problem. That's the kind of crap I can throw at you. It is not memorization. It will not work. You have to practice. It is not a matter of even just simple, just figure out a tactic, figure out some kind of question you want to deal with using a hash table. Do it. That's it. It involves just doing examples that you can make up on your own. It's not crazy pants, not rocket science or anything like that. It's just getting comfortable with whatever data we throw our way. So yes, you could have make a queue using a linked list, make a stack using a linked list. It could be make, we're going to do a course registration thing with a linked list, with the hash table. Why? Because I need to quickly be able to find objects. I want to make sure I don't have repetition in there. This particular hash table is a little bit weird compared to what we had before, because if two things go try and get put in the same place, I get a collision, but it's not really a collision. I actually just store both of them. I have a linked list at each one of the positions in my array. So it's a table of linked lists, and each linked list holds a bunch of items. So that would be, or I might ask you to extend the hash table so that we add a function for getting the length of the size of the hash table. Right? So you don't want to, if you've already done an assignment problem, there's no point doing it again because now you're memorizing at that point in time. You're not understanding something new. If you've forgotten everything, yeah, go ahead, redo that assignment. Great. But probably not. Most people will have remembered some part of it. So there's no real point redoing what you've already done. I'm not going to ask that question on the exam. There is zero point to memorizing it because it doesn't show up like that. It shows up as, here is a problem, do the problem. A brand new problem you haven't seen before, because it's about being able to, like, when you do a math problem, you don't get a math problem you've already seen before on the exam. You get a brand new math problem. And I know high school ruined you guys. And high school was, hey, by the way, you've memorized this formula where you plug and chug a bunch of numbers. Go. No, that is not how universities are supposed to work, right? It's about how you think through a problem. All right. So that it was a great question, by the way. So the best way of studying is just practice with these things. Make sure you understand other assignments because a variant on those assignments can show up. I can ask things about model view controllers. That's assignment 5B. I can ask questions about that. It will not be do assignment 5B. It will be something involving the data from 5B. It will be something involving how we separate things into model, a view, and a controller. Data, how it's painted or how it's drawn, how I control user input and timing of events, right? Model, view, controller, and how events are handled, right? The idea that I do not want to worry about how things are synchronized. When I get a paint method, I blindly paint. I don't think about how painting works. I just paint. And when I'm painting, I'm not changing my data. I'm just painting. All right. So hopefully that clarifies things because I get a lot of people asking, hey, should I just redo the assignments? And I've never understood that myself. And so maybe I'm biased. It's not that useful of a skill, although I understand why people might want it. It's a whole lot better though than just trying to memorize the slides. That's a waste of time, right? With slides, with anything like a textbook, you read it once, you're done. Stop, go on to actually practice stuff. All right. Dan, do you have any questions so far? I haven't really even got it going yet, but I wanted to see, I wanted to get the overview first before we get going. So or no? Why not? Now, I normally make it so that you don't have to submit the CVP files because sometimes it's slower. So just copying and pasting from a text document or just typing it directly into a field would be fine. Those are considered acceptable approaches. We are not running the code. How do I want to frame this without getting people into trouble? In 1400, I just had a TA who was taking off people's marks for their code not running and compiling. And I went, what the hell are you doing? No, 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 no. Code does not need to compile. It's an exam. You're under exam pressures. I expect you to know how to do things, but whether you have missing a semicolon or something like that should not be the thing that makes or breaks your exam grade. It's about understanding. Yeah, I don't need to run it. I'm not running it at all. And so if you give me code, I've had this as well for 1400, as you might imagine. I think I even got it from you guys at one point. If somebody just hard codes in the output, so I add these four things to my hash table, I should get this. And they will hard code in what the output is with a bunch of cout statements and then say, hey, my solution works. And you're like, you just hard coded a bunch of cout statements. How stupid do you think I am? Right? It's common, right? I might, if I was desperate too, if I was like, oh, I don't understand it, I might do the same thing. That's fine. But it's not, we're looking for how close you are to this nice generalized approach you can be. So let's make something different. I got to look at something first though, because what you'll notice about this hash table thing is, hey, it's all in one header file. The reason it's all in one big header file is because we are using templated data. Template class T, as in the data being stored in here is of some class T. What's T? I don't know. I don't know what it is. I will figure it out later. I will figure out what gets stored in my thing, and I will make a brand new hash table class for each different type of data that gets stored in there. So if I have a hash table that takes in LL data, I make behind the scenes. I don't get to see it at all. The compiler gets to see a brand new class that stores LL data. And if I have a different class, it has a brand new class that stores student data. So we'll generate multiple classes, which is bonkers in my books. So we're generating a whole bunch of classes with templated classes, but they have to fit a certain prototype. They have to fit the template. They have to look, behave exactly like all the other stuff. That's what we did with standard template libraries. When we used a list or a queue or what was a priority queue, or when we did quick sort, all this sort of thing, all of those functions work. All of these classes work because they say, hey, give me data that fits this particular pattern and I will be able to use it. Okay. So let's do that. Let's make a brand new class. I need to find out what LL data is. So LL data looks like this. I'm just going to copy and paste this because I'm lazy. All right, let's make a brand new class. I can add a new. All right, so let's call it student data something. All right, I'm just going to make it look and behave almost exactly like LL data. In fact, that's why I did this. So that pragma once, okay, there's a 6. Okay, remove this thing. This is just me being lazy. All right, so what do I need in this class? Let me think about this. So here's my class. It's called student data. It doesn't have anything special about it. It has a constructor. It has a constructor with a particular, let's put an ID in there. Um, let's put a name in there. This whole thing is going to be ID and name string. All right, and we're going to have a name. Oh, and then we're also going to have a double. So the student's average and their GPA and a bunch of other things. That's at least the plan of attack. And we go. We have to check to see if two of these things are exactly equal to each other. That's the to compare thing, this equals operation, if I wanted to extend that class. All right. I need to be able to output it with some kind of string at the end. Okay. What other functions would I want in this thing? So let's put some other things in here. So the name, GPA, we're going to just give it a generic GPA or average. Grab this, void set average. So these are our mutators and accessor methods, better known as getters and setters, right? Because I don't remember mutators and stuff. Maybe mutators because of X-Men, but other than that, it's getters and setters for a lot of people. I'm going to get a particular average. I'm going to be able to set the particular average. I can get key, which we'll look at in a second. Set the value. Do I need a set value function? We're going to find out if I need that particular function. The set value might be something very different. I might need it, not need it at all. So I'm going to leave it alone for right now, just because. Okay, and I have a toString. Let's do, I'm going to keep it lean and mean. The reason I'm keeping it lean and mean is purely because I don't want to have to write all these getters and setters, because that's not the point of this question originally. Okay, so I'm going to get the average, set the average. That's fine. All right. So, that. All right. And this is my header file. So now I'm going to need all this stuff here. So I'm just going to plop this down. Again, I'm lazy. Student data. All of these are going to be those. Uh, all right, I need something. I'll need something for there. I'm just putting off for a second. The toString method, I'm going to average. That average should take something in here. All right. All right, let's see what I got here. So what is this thing actually doing? I need to set some values to state values. Average is equal to, let's give everyone a 50% just for showing up. That's fine. Name, the name. I forget how to call it. So, hey, let me use this operator. I have a terrible memory. Don't remember how it's called? This. It'll do autocomplete for me. That's why I do it, because I'm lazy. Is equal to David Sprague. Everyone's going to be David Sprague unless I tell them otherwise. That's fine. ID is equal to 1, 2, 3, 4, 5, because I'm not very original in my examples. Here we go. I'm going to move this down here. And we're going to do the same thing again. But instead of the average is going to be the same, the name is equal to name. I should probably call it a different variable. Notice I need the this pointer in this case. I need the this pointer here because if I just put the word name, I have a member variable named name, and I have a local variable named name. And if I don't put the this here, it means use the local variable. That's the first priority, which leads to wackiness. Okay. And we have an ID. Oh crap, I'm going to need the this ID thing again. So this ID, and some people swear by doing this, by the way, using the this pointer, because what variable is this going to? It's going to the ID variable. That's the reason we do it that way. All right, get E is just going to return the ID. That's fine. Set the value. I'm going to set the ID to whatever value is. I'm going to check two students are equal. So what would make equality? Well, to compare and the current. So I have two objects, like two students. They both have an ID. The unique identifier is not the name of the person. There are multiple David Spraggs in this world, surprisingly. Yes, there are. There's actually multiple in Ottawa. One of them actually can use his hands, and it is not me, obviously. They are doing like construction and masonry, I think, in Ottawa. My sister took a photo of the guy's truck. So there are multiple people with the same name. Like John Smith is like this ridiculously common name. You don't need that. We need a unique identifier, which is, hey, your student ID. So If we want, we can just use this again to be like my ID. Okay, I could do this, return, is my ID equal to compare, and I should be able to, capital C, I should be able to get direct access to the other person's ID right there. If they're, uh, if they are not identical, then you don't got the same person. That's what we're looking at. All right, we need a toString operator. What did I do with LL data last time? Let's have a look. ToString and then whatever my data value is. Right? Okay, that's what I'm going to do. I'm going to take the ID. I'm going to get something about the name and a bunch of stuff. So I could have PD. My return value is going to be equal to this is an overloaded operator. The plus operator is overloaded for strings. It does concatenation. Get key work here. To compare get key would work in this particular case. But if I was going to be safe about it, I would get my own key, get the other student's key, compare that, right? Because I don't want to be knowing. In this case, I'm saying, look, the IDs have to be matching. This is assuming that the key is going to be the ID, which is not necessarily the case. And so if you want to use the key, get key for that, then you've got to be, you should probably keep it consistent and say like both of them, get both of their keys. Now, I'm not going to assume that ID is going to become the key, but yes, you could definitely use get key. I would have used this get key is equal to compare get key instead. Even though it's going to be the ID, I want it to be key to key, just in case. Because if I change the key of value around and use this, just say the string, the name of the person to be the unique identifier for this object, then I'm in trouble. Yeah. All right. So then we want, what do we need? Name plus, there's space in there, plus, let's put a this there, something like this, plus, oh, I need this toString thing that I copied from earlier. I want it to, and not data, it's going to be the ID, convert to a number, plus, plus, as average of, plus, string, and then I want average here. All right. So that's just making a string. This is going to be, let me just write it out as a comment. Student David Sprague. 1, 2, 3, 4, 5 as an average of. That is what I would expect from this thing as the generic case. And then I return that. All right, let's get the average. It returns the average. That's fine. Set the average. That's fine. Private variables are not used at all, so that's fine. All right, that should do it. I'm going to need to do something else. I'm going to need to, let me see here, change my main file. I'm going to include, where's all data? I'm going to include data. I want to make sure that that works. And the only reason I'm doing this is I want something to test my code. So let's make some things up. Test hash, void test student register. I just want to throw everything in one function here. In fact, I can turn off the test hash if I wanted to, but I'm going to leave it on. Test student register. That's all it's going to do. Okay, so let's have a look at what I'm going to do here. So my plan of attack right now is I'm going to make a whole bunch of these student objects. I'm then going to plug them into my hash table. Hope for the best for now. So let's do this. Student data SD1, very original, is equal to, and I have two different constructors here. So actually, topic constructor. There we go. Student name and the ID. So let's say 1, 2, 3, 4, 5. John Smith. That'd be overly original here. There are going to be different John Smiths. This is going to be a person with the same name with a different ID. That's not going to be very useful. I want to see if two things are equal, but that's about it. And in this case, I can have duplication, by the way. So let's do a duplication. This particular hash table allows duplication. I can save the same thing multiple times. I will need to have different names for these things. 2, 3, 4. And that put me in there. 3, 4, 5. All right. So I should have a duplication going to the same spot. For better or for worse, that is going to force me to have a duplication. So that's nice to have, just to test my code. I could also have something like a for loop in here and just make a crap ton of these things. So let's do that. What the heck? Hash table. And this, what am I storing in my hash table? What kind of hash table is it being stored in? This is a hash table full of student data. All right. That student hash. Okay. I'm not suggesting that I'm not suggesting any kind of particular lifestyle choice when I say student hash. Okay, insert SD1. That's what is going to be going into this hash table, right? 2, 3, 4. Oh, I needed 5. All right. And then print some data at the end. Good enough. That'll do. So let's have a look. Let's see how this all runs out. I love how people are coming and leaving so much. All right. I would have thought this would be a very, very busy, unless do you guys have an exam or anything right now? I would have thought this would be a lot busier of a session given the fact that I'm talking about how you would actually practice and study for the exam to save you time. But everyone can do things their own way. So I have made a brand new student hash. This student hash here, it's going to store a bunch of stuff. I'm then going to insert a bunch of items into the student hash. Heck, what the heck? I'm going to add the same person a second time because. Okay, and now let's see what happens when we print it off at the end. So let's have a look at what we have. I've run the code. Hopefully it's going to, boom. All right. So let's have a look. Hey, look at all this. So here is, there should be a break in between. This is my old hash table here. Here's my new hash table here. I don't know which element in my array I'm in. So what I should have is something like, I don't know, the out and L. That's probably better. Next time we'll see with a break. All right. So Don Smith 3333 goes has an average of 50. Don Smith 2222 has an average of 50. 1111 has an average of 50. Another John Smith with the same average has an average of 50. Notice two things: one line of hash table because it is in a linked list. This is a bunch of linked list items. This is a table, an array of linked lists, and if I have more than one item added to it, it just keeps on extending. Ideally, though, when you're talking about students, let's say you have Carleton students, if I have a hash table and I have 400,000, no, 400,000, let's say 40,000 students, you can still use a hash table, but invariably with 40,000 students and let's say a table size of 80,000, you're probably going to have a collision. You're not going to have many. The ideal is, or the hope and the dream is if your hash table looks good, it's going to spread them out over the entire table as much as possible and then insert them in the right position in the table. And if I have a collision, I have two students that would happen to go in the same table. You can deal with it. The linked list allows you to put multiple students in, but normally you don't have more than like 2 or 3 of those. Most of it's using the full array like this. That's what it's for. Okay, that's why it's fast, because I can jump to the particular position in my table. All right, I'm going to make a class. By the way, again, stop me if there's something that's confusing you. I'm going to make a class that is using the hash table. Why? Because I can. That's about it. And we'll move all of this crap over somewhere else. So I'm going to make a student registration thing. I'm going to generate a random set of student IDs or numbers or something like that. And the same name, just because the name is not going to make any difference to us. It's going to be way bigger than the size of our hash table. I'm going to add them all in there and see what we get. So I'm going to make, and then I'm going to get find, I think I can do find here. I'm going to find an individual student in the for registration. With me so far? So I'm going to make a new class that uses the hash table that allows me to stuff things into the hash table and then just access it. So let's make this new class. So new class. I always get a kick out of the name registrar. It sounds like you just spelled it wrong, but anyways, it was a very confusing when I was an undergrad. Okay, so here's what my student registrar has. It's going to have a private hash table, which I know has to have student data in it. And we're just going to call it hash because we're not overly original. I don't even need how big this hash table is at all. So I'm going to leave that off. I could put it in there, but I'm not going to. I'm just going to have a hash table. And I'm going to have I actually don't need a constructor, but I can put in a constructor if I wanted to. I don't need, so let me see, what are the things? I don't need a destructor either. So actually, let's keep it simple. Don't need a constructor, don't need a destructor. Why? Because that hash table, I'm just making a hash table. I don't have to call new, and therefore it's not dynamic and not dynamic object, and therefore I'm fine. I do not have to call new, and therefore I do not need a constructor, and especially do not need a destructor. I don't need to do anything on the takedown or the teardown of the structure. What other things do I need to have? I'm going to have insert or add register student. There you go. Okay, and student data. We're going to register a student. We're going to check to see if that student has already been registered. I'm going to need to include student data class. All right. Also need to include the hash table. All right. What other thing do I want? I might want to, I can find out if the student is there. I might be able to recover or return the particular student based on like an ID, for example. I don't think I have the ability to remove. If I look at my hash table itself, I don't think I have a remove in here. I was trying to make it simpler for you guys. As element, insert, print. Oh, I do have a remove. Go me. All right, let's do that. That and what other things do I what else might I want? I'm going to leave it alone for right now. But we should be able to find the individual student. I'm going to leave it like that. Okay. Those functions, my classic error, in case you haven't been paying attention to my classic errors. There you go. Fixed. Student registrar. So every single student registrar has a hash table full of students that you can access to figure out who is registered for your class, or maybe you can get the schedule for that particular student, or if they paid their tuition or what their average is. Notice it does not give us the ability to print out all the students necessarily, unless I say, hey, hash table, like inside here, hey, hash table, who are your elements? I don't necessarily have all access to all the data. So register a student. What I want to do, I want to make sure I don't have the same student multiple times. Let's say I'm doing that. Okay, so if has student SD turn, otherwise I want to hash dot. So I'm going to check to see if it's already in there. How do I do that? I don't know. I'll do it later. This is one of those, I know I'm going to have to do it later. Okay, I'm going to figure out, I'm going to insert into the hash table. And I'm going to insert SD. That should do it. That's it. As the student, now I need to figure out how to figure out if the thing is in the hash table. Well, let's look at hash. I know I have this member variable named hash, which is a hash table. Hey, I have a function for that. Great. Has element takes in, it takes in a key and determines if that key is in there. Does it only have that? Let's see. Has element. Let's see. Insert print data. Let's see what the hash only has the key. Okay. Sorry. So S. I'm going to get the key from the hash table and use the hash table and just say, hey, by the way, do you have this thing? And so return this. As element returns Boolean. Great. How about the remove student thing? I need to be able to remove that individual student. So I need to figure out if it's in the hash table first. Hey, yeah, same thing as before. So I need to say if it's not in the hash table, just return. Otherwise, hash dot remove and SD. Now this is using a pointer to that. So I'm going to use that here. And I'm hoping that's going to work because it's asking me, this function here says it's taking in a pointer to a student data. That's a pointer to a student data. We're going to find out if this works. Should work. Okay, my main function, my main file. La, la, la. Student registrar. All right, and now I'm just going to go right back to down to this thing here. And instead of testing the hash table, I'm going to let's keep doing this part. I'm going to make a whole bunch of student data. So that's still fine. Student registrar. All right, I'm going to make a sample registrar. That's going to make a hash table automatically. The moment I get that line, boom, I make a hash table inside of this object called TestReg. From there, I'm going to be able to, I need to be able to do stuff with it. So TestReg dot register student SD1. There we go. And it's just going to be this instead of this insert thing I had before. Okay. And then here's the issue though. I don't have any way of printing off who's in my, so maybe I want that as a, I'm going to add an extra function in here. Student registrar. I might want something called print data or print roll. Yeah, sure. Void print ROLE. No, it's ROLL, like student roll, as in roll cylinder, not as in role playing. Hash dot. Let's find out what my, oh. All right. So here's my class. Here's my particular function in my class. I'm going to get my hash table, get access to my hash table, and just call print data. And print data should just, it calls a print, it calls cout a bunch of times. So it should just print off everything in the hash table. So let's do this. Cout. Like that. Here. That's going to do. Let's return a value. Remove student, let's return a value. Okay. Does it remove return anything? Yes, it does. Return that. And this will be return false. It didn't remove anything. So if it returns it successfully, returns true. Otherwise, it returns false, as in nothing was removed, nothing's changed. That doesn't mean I failed. It just means nothing was removed. All right. So let's also go back to this whole main file thing. I want to put in TestReg dot print the roll. All right, let's do that. And I said I was going to do this before, so let's do it now. For I is equal to 0, I is less than 300, I plus, and I'm going to have I plus 52, just some random number. 1, 2, 3, 4, 5. Let's do that. Just a random ID. Generic Q student. That's what this person's name is. All right. So a generic Q student that's going to be added onto this thing, and then test reg dot register student, and that student's name is temp. Put that student in there. Then I'm going to print off the roles afterwards. But I'm going to add 300 new students, just random students into this thing. Let's see what happens. Because, all right. And they're all going to go to weird places. Why? Because it's I plus whatever this number is. So presumably it's just going to keep on going through my list, just filling in all the gaps. But you never know what that hash table is going to do. It's just based on the key. All right, so let's have a look at what we're going to get here. So I'm going to walk down this. I'm going to just spew out a whole bunch of students, throw them in this hash table, and then we're going to print off the resulting it. Oh, but let's also remove a student. So let's maybe find a student. We need to do that too. Okay, has student. Oh, I'm going to need that student ID thing again. I can check. I want to check one of these generic students in here. I'm going to make a brand new student, but it's just some generic number. I'm going to put like 52 plus 1, 2. So one of these students should be already in this array. It's some number. This number here is one of the IDs in here. Why do I know this? It's because I is between 0 and 300. 52 is between 0 and 300 plus whatever this number I'm adding to it. So that ID got to be in my queue or in my queue hash table. So I'm going to find if that student is already in my hash table. Just to see if it all works. And if I want to be very, very careful, I could do something, or I can do something like this. I'm expecting, just because I want to test, do I have an assert already made? If I don't, I'm going to add it. All right. Some kind of test. Oh, that's what the problem is. It's not that at all. It's there. Nice. Okay, so I'm going to check to see if that student is in there, and then I'm going to print the whole thing out. Let's find out. Let's see it in action. It may not work. That's okay. Ooh, that's a lot of stuff. Maybe generic Q student was a bit too long-winded. Okay, so you can see all the generic students in here. Let's see if I have. So here are the elements. This is one linked list that put a generic Q student in there. Here's another linked list that put a generic Q student in there. I put too many things in here. Outputting the registrar role. Here's 1, here's 2, here's 3. Like, it's a bunch of things. I could put a smaller number than 300. That was way too big of a number. Let's do a smaller number just to see it in action. So let's see. That's then 40. This is Visual Studio syncing with Google. It's not anything to do with the code. Oh, we have a problem. Oh. What is no longer true? 52 is not in the range of numbers that we have. Let's make it 21. All right, let's run it and see what happens. Boom. All right. Elements, generic Q student is in there, has this average. Generic Q student, we've added 1, 2, 3 generic Q students in there. That's how many elements I've added. We actually don't know how many elements there are in this thing, but it's 1, 2, 3, 4, 5, 6, about 20 elements, let's say. Approximately 20 elements. That's how big this table is. If the table was bigger, you wouldn't have so many overlaps. In fact, we can play with that. Let's do that. Hash table. What's the default size for our hash table? Default table size 20. Let's make it, I'll just put that in there temporarily, but let's make it 51. Why? Because let's see what happens. Remember, this should spread out my numbers randomly in the table. I might get a couple collisions. One collision here, one collision here, collision here, collision here, collision here, collision here. There's not, I have a 3-person collision here. And notice I still have some where I have empty elements. It's not going to all perfectly distribute across this thing. In fact, let's look at what the hash table is actually doing to get the hash. It is multiply whatever that key ID, I43, then do remainder 497 because what the hell, and then table size because again, what the hell. If I did 51 here. So if I did 131, I don't even know if that's a prime number or not. I want prime numbers because it means that the math just works better. You don't need to know how that works, but the math works better. Let's have a look. No collisions, just a whole lot of wasted space. Look at how much wasted space. And notice something weird about this. It's banding. I get this huge gap. Here are these, here's a for loop adding in sequence, and then this huge gap. There's something weird about my hash function. That's why it's banding like this. Fine. But this is the kind of thing you worry about when you're making a hash table, because what you want is it spread out as much as possible, and no hash table is ever perfect. It will never fill up everything perfectly without a collision. You'll either have a whole lot of extra space or you'll have collisions. You can't guarantee a perfect hash table where everything gets perfectly spread out unless you really rig your system. So there's me making a class with a hash table. In case you want to know, that would have been a perfectly fine exam question. I would have had to make it a bit clearer and not meander around as much, but that's what you could do. Instead of a student registrar, though, it would just be storing LL data in there. Because I gave you LL data, it works. It gets stored perfectly fine. So maybe store random numbers into a hash table and see how it distributes. That would be an example. That would be something you could practice with. Does that make sense? Can I clarify anything? I have other linked list demo here. Can I clarify anything on part of that? There's only 2 of you, so. You want to look at MVC? Great. But that's I want to fix things, and other people didn't show up. So, so do you understand where you're trying to be practicing with this? It's not going to be memorizing. It's going to be look at this, understand it, add to it, play around with this, download the files, make a new project, do a bunch of stuff with it, right? Play with it to make sure you understand how the code works. That's the easiest solution. That's why I'm giving the code so that people don't go, I don't remember what a linked list looks like. I'm sure it was in multiple lectures. We added to it multiple times. Seriously, if you didn't see those videos, then please watch it. I'm not saying you guys, but other people watching later on. If you didn't see the videos, watch them now, or you should have watched them, because that's what the expectation is. You had watched the videos, then you do the assignments, you practice in the labs, and then you do the exam. We have iterators. Do you guys have problems with iterators? Do you want to look at linked lists? Do you want to look at, let me see here. What would be a good use of a linked list? We can make a queue if you wanted to with a linked list. That's kind of predictable. We also don't need an iterator for a linked list. Why? Because, oh, sorry, for a queue. Why? Because you know the front, you know the end. You're not supposed to know what the middle is. It's supposed to be this random magic box that you stuff things in, and the thing that was in the list, the first pops up the list the next time you pull something off. So first in, first out, like a queue, like a lineup when you go to a store, right? You line up, you wait your turn, you get to the front of the line, you get to go out. That's what a queue is. Sure. Do you want a queue or a stack? Which one do you prefer? Sure. Let's make a queue. All right. So I'm going to add a new class. And I think I called it LQ. So we also need to figure out what the heck queue has. Queue has particular terms. It depends on who you ask. It's not as written in stone as it is for a stack, but it's the same kind of idea. So a stack, like stacks, tray stacks, right? It's first in, last out. So the more trays you put on top, the thing you put on first is the last thing to go, right? Or, oh, parking lots. If you're going to a parking lot or like some bad situation like that, where everyone, or elevator, right? Everyone back in the day when more than two people could ride the elevator at a time, everyone piles into the elevator, and the last one in is the first one out because they're blocking the door otherwise. Same with the subway or anything like that. So that's what we're looking at. Are these updated codes going to be available on the drive? Yep, they're already on the drive. That's why it automatically syncs. But you can get the original code also on CUlearn as well. But yes, what I'm writing right now, it's in the sync lecture. Hopefully I don't give away anything for provided code. Here we go. So hopefully, here's a sync lecture you had access to the in-class code folder under sync. And then I think it's provided exam code right here. And then it's all the various things that we worked on. We were just looking at provided demo. This one, the MVC shapes does not have code that runs because it's just some shape class that are useful. Put them into your MVC code, see how they work, right? Make sure that you understand how they work. They are actually straight from the lab, if memory serves the solution for the lab. Great question. All right, so we're going to make a queue. What does a queue have? Well, I'm going to need something in my queue. I'm going to have a private. I don't need a pointer to a linked list like I have in the past. I need pointers to things if I'm going to, build them up later, right? If I have to figure out what's going to go in them later, I need pointers. The linked list itself has pointers. It has each one of those nodes. It's a pointer to a node. But the linked list itself, I could just have a linked list in this thing. So I'm going to make sure I put in my linked list class. Right. Do I want to make it take generic things? I'm going to make our lives a little bit easy. Oh, no, it's not templated, so we're good. It'll take in what it wants to take in, damn it, nothing more. So here's a linked list. So LL, because I'm not very original for linked list. And then what do I need? So every one of my queues has a couple functions it always needs to have. It's going to, well, I might want a constructor or a destructor depending on how I want to view things. Really depends. In this case, I don't think I need a constructor or destructor. We can modify the code later to make me have a constructor and destructor. That's perfectly fine. I have an enqueue and a dequeue. Those are the terms that we use for it. So, boy, let's make a. And what gets put on this thing? Well, I happen to know that my linked list node, let's see what linked list nodes have. They have LL data. LL data is stored in linked list node right here. It's a data structure. That's what all of these things are just storing. It just happens to be a number. It's just a wrapper for a number, but it's an LL data. Okay. So let's look at this thing. The enqueue is going to take some kind of LL data, some kind of data I'm going to store in this thing. To add, go. This one will be LL data DEQUE. It's going to remove the tail of, so it depends on how I want to do this. I could do it either way. I could start at the front and pop off the tail, or I could add to the tail, pop off the front. Both are fine. Depends on what my linked list, how my linked list is implemented. I want to look at my linked list for this. So it's going to just DQ, and I'm going to call DQ. I sort of want to make sure that if I call DQ and this thing is empty, right, I want to make sure that I'm not allowed to call DQ if it's empty. Maybe I'll just put an assert in there. I want to see if it's empty. So Boolean is empty, or I can give size. That's the same thing, essentially, in the end. And what? So I can add, remove. I can get the head. So LL data head. All right. You could also say that DQ doesn't return anything at all, and it just removes the front. Both would be fine. Depends on your philosophy on this. All right, that's it. That's the grand total of what I need to do here. LLQ, where's it now? So lazy. All right. So what does enqueuing something? I have a linked list. What does dequeuing mean? I have a linked list. And what does this do? We're going to have to figure out what all this stuff does in a second. So I want to look at what my linked list does. So let's have a look. So I can get the last. I can see if something is the first. I can insert at the front, but I can only get the last. Can I remove? I can remove from the last. I'm forced to go one way unless I have removed from the front, and so I can insert at the front or the back, but I can only delete from the back. Remove from back. I don't have remove from front. Since my linked list has this limitation, I have only one way I can do this thing. I have to remove from the back, add to the front. That's the only choice. I have an is empty, which is useful. Okay. So I have this linked list. I'm going to have LL, I know what it's named, insert at front, and to add, I'm going to insert at front. There you go. That's it. That's the grand total of it. Dequeuing something. That's why it was a possible exam question. That's it. Dequeuing something. Well, I want to, I can assert because I want to make sure this is fine. I'm going to assert LL dot empty, not that. If you're calling DQ, it better have something in it. All right. Remove from back. What does this actually return? is just returning a true or false. So I need to get the last one. Uh-oh. I might need to get last. I might need to change just because I tells you what this question can be on the exam. Then I get start. I don't have get last. I need to be able to get that last element because otherwise there's no point removing from the front from the back. Because remove from back, it's only returning true or false whether I have removed something from the back. It didn't get me the last element. I like that. Okay, so I have a linked list. The linked list may not allow me to do this, but I might be able to do some other thing. So let's use our iterator and walk to the end and get the last element and then remove the last element. So get start. This should return, this is returning an iterator. Here's my iterator. And I want to say while iterator dot as next, while there is a next, I want to say iterator is equal to iterator dot. Actually, I just want to iterator next, isn't it? I don't have to save it. Yeah, it doesn't return anything. So I'm just going to keep on walking down. My iterator points to the front. I just go until I run out of things. There's no other element afterwards. The iterator is the last element now. So LL data to return is equal to iterator dot get value, the value for that iterator, storing it in here, removing from the back, return to return. I could have done this. All right. And I can just return, and now I'm returning my element. All right, this one's easier. So this is how an iterator works. I don't know how the linked list is built. I get the start. I don't know how it's struck together. It could be using an array. I don't know. I don't care. I get the front element, and I use my iterator to walk down this linked list. Linked list dot is empty. I have that function. Okay, that's fine. Return that. All right, let's get the head of my linked list. That's this thing here, the start. Notice I don't need to know how it's built. I just give an uniterator. What's an iterator? I don't know. Some kind of object. It iterates. It's the bookmark in your book. You don't care what the bookmark looks like or how it's doing. It's just holding your page in the book. Okay. Return iterator dot get value. All right. And I want to do one more thing, which is I want this thing to blow up if you tell me, hey, I'm going to use it. I'm going to give me the head of the queue for this. Wait a second. I'm doing it wrong. And I'm going to have a problem here. I'm going to run out of storage soon. So let me pause the video for a second, just because I'm going to run out of storage. But then we're going to keep it going. Okay.